Hello students, we continue reviewing the trig functions and we're going to discuss graphs of trig functions in this small lecture. So graphs of trigonometric functions. Alright, so first of all, we would like to talk about y equals sine, but here we'll have a change of notation. From we will use x, but not for theta. Sorry, we'll use x for theta. So I'll put here x. And what's the reason? Because I don't want to move around circle anymore. I want to put a graph for the xy plane, and so my variable is x. So it will be a little bit confusing because of the notations that we used for unit circle. And in the unit circle, we have angles, and so angle now will be x, so it's a little bit confusing, but so what kind of points we have in the unit circle? We start at 1, this is 1 here, -1, -1, and we can go around and build little table for x and sine of x. So if we start at 0, if you remember, this point is 1, 0. This point over here is 0, 1, 0, 1. This point over here is -1, 0, and this one is 0, -1. So what's going on at 0? Sine by definition is y value over r. Our r is always 1. So if you remember in the unit circle, the y value just represents your sine, right? So 0. So we get 0 over here. Then we can put something like pi over 4, pi over 6 first. Pi over 6, so we're going to get 1/2. So we're going to get 1/2 at pi over 6. Then at pi over 4, we're going to get 1 divided by the square root of 2. So we're going to get approximately 0.71. Approximately 0.71. Right, so it's close to 1. So basically what happens, our function goes up to 1. Where do we reach 1? The y value equals to 1 over here. But then the values get smaller and smaller, y values get smaller and smaller, so we're going down to 0. And where the 0 happens, here's the 0 for y. So it's at pi, and this was pi over 2. And then we're going to reach -1. We're going to reach -1 by 3 pi over 2 by this point. And then we're going to come back to 0. We're going to come back to 0 at 1. Sorry, we're going to come back to 0 at pi, 2 pi. We went full circle. But then our function will just keep moving, doing the cycles, because sine keeps repeating when we move around the circle. And also the same kind of a cycle this way, right? This would be -pi over 2. This will be -pi. negative 3 pi over 2, negative 2 pi, and it keeps going. So that's the graph of sine. This is a graph of sine. And the same we can do for y equals to cosine of x. So let's think about cosine. Cosine pretty much on the unit circle coincides with the x value. So if you think about angle equal to 0, the x value is 1. So the cosine starts at 1. But then as you can see, if we move up, our x value gets smaller and smaller and smaller and goes to 0. So we have something like this. Maybe not really accurately plotted. Yeah. All right, so by pi over 2, we're going to reach 0. So over here, we have x value 0. But then x becomes negative and it goes to negative 1. So this is negative 1, this is 1. So by value of pi, we're going to reach negative 1 for x. Then we're sliding back to 0. Sliding back to 0 by 3 pi over 2. And by 2 pi, we're going to come back to 1. By 2 pi, we're coming back to 1. So it keeps going like this, right? Keeps going like this. So by here, it's negative pi over 2, negative pi, and keeps going this way. And so this is the graph of cosine. The next graph we're going to need is the graph of a tangent. So tangent is a little bit harder to understand. So let's try to do that. Y equals to the tangent of x. And as remember, on a unit circle, it's the ratio of y to x. So if we go back and replot our points, mistake. So it should be 0, negative 1. All right. So what's going on? So it's y over x, this value over this value. So let's do this. So let's try to do the tangent. So if we take 0 angle, for 0 angle it will be 0 over 1, so it's going to be 0. There's nothing wrong with 0. This is perfectly fine. Then let's try to move along. So as you can see, the y value gets bigger. But x approaches 0. So eventually we will have something like 1 over 0 when we're pretty close to this point. So 1 over 0, what does it mean? That means our limit will be when x approaches pi over 2, this angle, our limit will go to positive infinity. Why positive infinity? Because everything positive in this quadrant, but it goes to infinity. So by pi over 2, we have the following situation. Our values approach positive infinity. So this is what happens. If I move this into the negative direction, I'll get into the same situation, but y value is negative over here, so our limit will approach negative infinity. So by negative pi over 2, our function will approach negative infinity. So every time we get to this point or to this point, we'll get infinity. It's just the question. Is from which side we approach infinity, right? So this is a tangent graph, and it keeps going like this. This is 3 pi over 2. You see, 3 pi over 2, we get 0. Pi over 2, 3 pi over 2, and so on and so on. And this is negative 3 pi over 2, if we're moving into the negative direction. So this is a situation with tangent, a little bit more complicated. We have these lines, which we'll discuss in the future this semester, but they're called vertical asymptotes. So one definition that is really useful for us, and people define it in a little bit different way. Maybe you've heard it a tiny bit differently, but it's fine. So we say that a function is called periodic. If there is a positive value, positive number p, such that f of x plus p is equal to f of x, whenever x and x plus p lie in the domain of f. And this p has a name. We call p a period of the function f. But also we can get the smallest such p, because a couple of different p's might work. The smallest p has a special name, so the smallest positive period is called the fundamental period. The fundamental period of f. But most of the times people just call fundamental period just the period. All right, or most of the times the period of f. So when people say period, they actually mean fundamental period usually. All right, so we define this fundamental period. Let's try to figure out what would be the fundamental period for our functions. So we can say that for sine of x and cosine of x the fundamental period is 2 pi. So I'll write it first and then we'll go back to the graph and check. So what does it mean? Sine of x plus or minus 2 pi is equal to sine of x. We discussed it in the previous lectures. And cosine of x plus 2 pi is equal to cosine of x. Remember, we discussed it before. For tangent, the fundamental period is pi. Fundamental period is pi. So tangent of x plus pi is equal to the tangent of x. And let's look at the picture for pi first. You see, if we move pi units to the right, pi units to the right, pi units to the right, we get the same y value. You see, if you draw a line like this, you see that they match up. All right, for sine and cosine, it's 2 pi. So if you go here, right, you get it here. You get it here, it's just in 2 pi. All right, so let's do a few more examples before we go back to calculus course. It's not comprehensive. Probably if you struggle with it, you might want to go back and review this book that I published in the beginning of the Moodle page. So example 1. Example 1 asks us to plot y equals to 3 sine of x. So we have a number 3 up front, right? And we talked about this, it's a vertical stretching, so we start with the graph of y equals to sine of x, and then we're going to stretch it by the factor of 3. So we have a graph of sine. Oh, I didn't do the right work. Sine, right? Sine. I drew cosine. So sine goes up, goes to the middle, goes down, goes to the middle, and then it keeps going like this. All right, so this is the sine of x in black color. And we would like to stretch it by the factor of 3. So if we take this point and multiply by 3, 0 times 3 will be 0, so it wouldn't move. And if we take this point over here and multiply by 3, it will go to 3 over here. So our picture would be something like this. Then this is 0, so it will not move. So, and this will go down by the factor of 3, so 1, 2, 3. So it will be like this. So it's the same graph, but it's stretched out by the factor of 3. And it keeps going, right? Keeps going. I'll stop, but it's actually keeps going. And the same on the left side. So this point will be down over here, so it goes like this, crosses through 0, goes back up to 3, and then keeps going like this. So I'll stop, but we understand, and this 3 sine of x, 3 sine of x. All right, so let's do the last example for the review. And the last example for the review is plot y equals cosine of 4x. Cosine of 4x. So now inside of cosine we have this quantity which we can think of one variable. So 4x changes in 2 pi, right? Because if it would be just 1x, it would have a full fundamental period of 2 pi. So now 4x has a fundamental period of 2 pi. So if we want to convert it, what does it mean for x? We're going to divide both sides by 4. So this tells us that if we simplify over here, that means pi over 2 is the new period, right? The new period. So basically, if you draw your graph of cosine, the whole period now should fit into the pi over 2. Into the pi over 2. So let's try to do that. So the original cosine starts at 1, then by pi over 2 it reaches 0. Maybe I need to zoom out. So let me go up here. This will be 1, this will be pi over 2. So by pi over 2 we reach 0, then by pi we reach -1, then by 3 pi over 2 we come back to 0, and by 2 pi we come back to 1. So that's our graph of cosine, and it keeps going, and it keeps going. So now this whole thing will be squeezed into the pi over 2. Into the pi over 2. So basically we have to 1, 2, 3, 4. So all of these 4 points will fit over here. So we'll get something like this. So basically we squeezed in the graph into this pi over 2 neighborhood. I didn't plot it nicely. Let me redraw it. So it goes to this point, reaches 0 at this point, comes back to pi over 2 over here. Right. So we have pi over 8, pi over 4, 3 pi over 4, and pi over 2. And it keeps going. So what we did, we squeezed it in this way. All right, by the factor of 4. So this point here is, this point is pi over 8, which is pi over 2 divided by 4. This point here is 2 pi over 8, and this point here is 3 pi over 8, and this pi over 2 is 4 pi over 8. If you simplify 4 pi over 8, you're going to get pi over 2. If you simplify 2 pi over 8, you're going to get pi over 4. And that's the situation with this graph. So the red graph is cosine of 4x. Cosine of 4x. All right, so probably a good place to stop. And in the next lecture, we start talking about calculus again, and we can use trig functions. See you in the next lecture.